So good morning students. My name is B. Venkateswara, MSc MD Physics Faculty, Dokarvalsa, Super 60 IIT NEET coaching. Today discuss Lenz and conservation of energy. The direction of induced EMF always such that it tends to produce current which oppose the change in magnetic flux. That is called Lenz law. In Faraday's law, E is equal to minus d pi by dt. Faraday's second law. So here, when circuit is closed or open, induced EMF also produces. When circuit closed, only induced current also produced. So when a coil held horizontally, and bar magnet dipped into the coil, mg downward, f upward. In both cases, south and north. A less than G. So here, length along to the axis, length along the rotation of the axis, F net equal to mg minus f. So length along the rotation of the axis, F net equal to mg minus f. So a net equal to mg minus f. So a net equal to g by g minus f by m. So here a less than g. A net is less than g. In both conditions also. Here force acted on the coil of the magnet. Second case 2. Cutting coil. So this is a coil not closed. Here south north, mg downward, here less than g. So induced EMF also produces an EMF produced, no induced current, no oppose the motion of current, no oppose motion of magnet, no oppose motion of magnet. So cutting coil, mg downward, this is a cutting coil. Induced EMF also produce, no induced current. This is not a complete coil, that is cutting coil. So no oppose the motion of magnet, Two magnets, case 3, two magnets. So two magnets move the perpendicular to the plane of coil. Two magnets move perpendicular to the plane of coil. So induced EMF also produce induced EMF also produce, and the current pass through the A to B. So A to B connected capacitor. So current direction A to B and electrons direction B to A. Here A plate also positively charged. A plate also negatively charged and B plate also positively charged. Here A plate will be negatively charged and B plate also positively charged in this condition. So the direction of induced EMF, different kinds of motion of magnet, different kinds of motion of magnets. So here coil, taken coil, a clockwise direction. Magnets move magnet towards move the coil. So induced current clockwise direction. So another situation, coil, magnet move away from the coil. In this condition, induced current clockwise direction. So next one, motion of the magnet, rotation of magnet, no induced current. In this condition, no induced current. Okay. Next, effect of induced EMF, induced current, induced charge. According to Fleming, Lenz and Faraday's second law, according to Faraday's second law and Lenz law, E is equal to minus dy by dt. And number of points is equal to minus n into dy by dt. So E is equal to minus n into pi 2 minus pi 1 by dt. N is the number of points. Here pi is equal to n a b cos theta. So pi changes from the magnetic flux change from n a b theta. Pi change, magnetic flux change n or b or a or theta. Pi changes n number of bodies and b magnetic flux and a area and theta angle. First one, induced EMF. First one, B changes induced EMF, induced. So average induced EMF, average induced EMF, that is equal to E equal to minus NA cos theta into B2 minus B1 by T2 minus T1, B2 minus B1 by T2 minus T1. So here theta equal to 0 degrees, the maximum, that is equal to minus NA B2 minus B1 by T2 minus T1, T2 minus T1. So instantaneous induced EMF, instantaneous EMF, that is equal to E equal to minus NAB dB by dt, NAB cos theta dB by dt, instantaneous EMF. Instantaneous EMF equal to is equal to minus NAB cos theta dB by dt. Next, A changes. Second, A changes. Then A changes. Then, so average induced EMF. A changes. So E is equal to minus NB cos theta into A2 minus A1 by T2 minus T1. Then theta equal to 0 degrees. So E average equal to minus NB A2 minus A1 by T2 minus T1. So E instantaneous minus NB cos theta into dA by dt. E instantaneous, induced EMF instantaneous. So minus NB cos theta dA by dt. Next, phi changes. If rotation, coil rotation, theta 1 to theta 2, theta 2, theta 1. So average induced EMF. So E is equal to minus E is equal to NAB d by dt cos theta 2 cos theta 1 by T2 minus T1, instantaneous E INT, instantaneous. So NAB minus NAB d by dt cos theta. So theta equal to omega t. Theta equal rotation. Theta equal to omega t. NAB cos theta divided cos theta minus sin theta. That is equal to NAB sin theta. NAB, that is equal to E0. E is equal to E0 sin theta. Here E0 equal to NAB. So theta equal to 90 degrees. E maximum equal to NAB. 10 so omega t theta equal to 90, that is equal to omega t equal to 90 degrees. Omega t 90 degrees. Omega t is not omega t. Next, induced current. So magnetic flux of the coil resistance are changed from theta to theta 1, that is equal to induced current I equal to E by R. I is equal to E by R. So E is equal to minus d pi by dt. So E is equal to minus n into d pi by dt. The first equation, the second equation. From 1 and 2, so I is equal to minus n into d pi by dt by r. So I is equal to minus n by r into d pi by dt. This is a induced current. So I is equal to minus 1 by r into d pi by dt. This is a induced current. Induced current. Next, induced charge. Induced charge. Induced charge. Induced charge. So induced charge here I is equal to minus 1 by r into d pi by dt. So current I is equal to q by t. Q by t. That is a instantaneous. That is a dq by dt equal to minus 1 by r into d pi by dt. So dt cancel. So dq equal to minus 1 by r into d pi. So here q equal to integration minus 1 by r into d pi. So q is equal to, that is a pi f, that is 1 by r into, so pi f. So q is equal to minus 1 by r to pi f minus pi I. So q is equal to 1 by r into pi I minus pi f. Okay, that is equal to, so q is equal to pi I minus pi f by r. Change in flux by resistance. Q is equal to change in flux by resistance. Resistance of coil. Resistance of coil. So R is the resistance of the coil. So this is an induced charge. Q is equal to change in flux by resistance. Change in flux by resistance. So pi I minus pi f by R. R is the resistance. Pi I. So minus pi f. Next, induced EMF rotation of the coil. Next video.